So we're going to deal with the dimensional formulas. They just taught you what is area. Area as a SI unit, is meter square, but it's L to the power 2 is the dimensional formula. Then is volume. Volume is meter cube in SI unit, but it is L to the power 3. Then is density. Density, the formula is mass by volume. So it is m by L cube or ml to the power minus 3. There's no t there, okay? And this is a kg per meter cube is the SI unit. So you understand the dimensional formulas on SI unit. Then is velocity. Velocity, is distance by time, which will be L t to the power minus 1, or here meter per second. Acceleration. Acceleration is actually velocity by time, which is meter per second square. So it will be L t to the power minus 2. So then next is, let me teach you what is momentum. Momentum is mass into velocity. It's represented by P, mass into velocity, which is kg meter per second. But here it's m is mass and velocity is L t to the power minus 1 from here can be substituted. So momentum is ml t to the power minus 1. Let's talk about force next. Force, is F is equal to m into A. Acceleration's formula is here. So it's m into L t to the power minus 2. Of course, SI unit is Newton. So let's talk about work done. Next is work done. Work done is actually force into displacement, correct? Okay, force, it's actually joule. SI unit is joule. Force is ml t to the power minus 2. Displacement is L. Therefore, the work done itself is m L square t to the power minus 2. That's work. So let's talk about power. Power, is the rate at which work is done. Work is ml square t to the power minus 2 by t. So ml square t to the power minus 2 by t will be ml square t to the power minus 3. So it's ml square t to the power minus 3 is what is power, and the SI unit is watt. You already know that. Now let's talk about pressure. Pressure's formula is force by area. Force, actually Pascal is the SI unit. And here it's ml t to the power minus 2 by L square. This goes up, it will be ml to the power minus 1, correct? T to the power minus 2 is the dimensional formula for pressure. Now after this, our pressure is over. Whether work done and energy, both of them are same. Whether they ask you energy or work done, it's going to be ability to do work is energy, right? So that's about it. So next is, I taught you a new word in physics which is called torque. The other name for torque was moment of force, which I taught you using the door. The door, the handle is always at the far end, in order that this distance from the pivot is more. When it's more, the force will be less. The handle of force will be less. So it's a product of force into perpendicular distance from the pivot, from the end. Perpendicular distance is the formula for torque. And force itself is ml t to the power minus 2. Perpendicular distance is another L. So it's ml square t to the power minus 2. And isn't it similar to work done? Dimensionally, the work done's dimensional formula and torque's dimensional formula are the same. So if they ask you two physical quantities which has the same dimensional formula, you can say work done and we can also say torque. Like that you can compare and tell. Okay. So then you understood torque is the rotational motion. The fact that that's got a word moment. Momentum is different. Momentum is linear, straight line motion that you will get. But this is moment, which is rotational motion. So then the word moment is associated with rotational motion, and when you open the door, there will be an arc which gets subtended. There will be a sector which comes when you open the door, right? Correct? So that's about it. That's about torque. Next is gravitational constant. Gravitational constant is capital G. You already studied last year F is equal to G m1 m2 by r square. Therefore, capital G is Fr square by m1 m2. And so it's Newton meter square per kg square is the SI unit. We're going to write the dimensional formula ml t to the power minus 2 into L square by m to the power 2, because 2 masses. So it will become m to the power minus 1, L to the power 3, t to the power minus 2. Correct? So we can change it and we can say that it is gravitational constant is m to the power minus 1, L to the power 3 and t to the power minus 2 is the formula for gravitational constant. How did you get it? Is by writing G is equal to Fr square by m1 m2. Okay, next up, gravitational constant is over. So let's go to now I also taught you what is impulse. The cricketer's ball when they catch the ball, it's product of force into time. And so then its force is Newton second here as a unit. When it comes to dimensional formula, it's ml t to the power minus 2 into t, which is ml t to the power minus 1. So thus you get it as ml t to the power minus 1. That's about impulse. So next is, let's talk about solids. I introduced you to solids. In solids we came across this spring balance in which I will put weight on it. You know that it will get strained when I put weight, and we call it a stress. When stress is applied, there will be a strain. The strain is delta L by original length. That's called the strain. The extension of the wire is called the strain, and the pressure that I am putting is called the stress. Okay, so then therefore in solids you have something called the strain. Strain is change in length by original length. It will be dimensionless because, so it's a dimensionless quantity. Dimensionless quantity, correct? Well, let's talk about stress. Stress is nothing but pressure. Stress is nothing but like pressure, which is force by area. Force is ml t to the power minus 2 by L square. So it's ml to the power minus 1 t to the power minus 2. Of course, here stress is also Pascal, or you can say Newton per meter square, whatever you want to say, you can say this about stress. Next is, I taught you when there's a stress and strain. Young's is a scientist who found this. Young's is a scientist who found that the more the stress, the more will be the strain. So it's represented by Y, which is called modulus of, should I say modulus? I should say coefficient of elasticity. You can also say modulus of elasticity, but for consistency's purpose, we'll say coefficient of elasticity. Every metal in this world is also elastic. Everything is elastic. So then it's nothing but the ratio of stress by strain. You know, strain is dimensionless. So only stress will carry the dimension, and the stress dimension is the same here also. ml to the power minus 1, t to the power minus 2. It's known as coefficient of elasticity, or it's also known as Young's modulus. Young's modulus. Any name you can give, either this or that. Okay, so this is about solids. Then I taught you about fluids. In fluids, I told you take a beaker, fill it with water. These molecules are uniformly attracted by molecules in all directions. So this will be in equilibrium. Whereas the molecules at the surface will not be in equilibrium. They will be tensed. That is called surface tension. Okay, so the surface tension, they are asking about surface tension. The formula is force by length. Okay, force by length, which is ml t to the power minus 2 by L. So then therefore it will be m t to the power minus 2. That's a dimensional formula for surface tension. Then is surface energy. Surface energy, you know, you can multiply F by L with L by L. So it is nothing but energy by area. The surface energy by area. The surface of the liquid like energy by area. Energy is m L square t to the power minus 2 by area is L square. So you still get m t to the power minus 2. Name two physical quantities which has the same dimensional formula. The surface tension and surface energy seems to have the same dimensional formula. Similarly, Young's modulus and stress has the same dimensional formula. Correct? Similarly, torque and work done had the same dimensional formula. Like this we can keep saying about a lot of similarities. What are those which do not have dimensions? Strain do not have any dimension because change in length by original length. You understood all that? So now that's about fluids. You have surface tension, surface energy, and next is coefficient of viscosity. Coefficient of viscosity, from the fact that F is proportional to A, F is proportional to velocity gradient, F is equal to eta into A into velocity gradient. Therefore, eta, which is coefficient of viscosity, which is a proportionality constant, is this frictional force F into D by area into velocity. So what is the dimensional formula? Force is ml t to the power minus 2 into distance is L by L square into L t to the power minus 1. L and L get cancelled. This goes up and become m L to the power minus 1 t to the power minus 1. It's a world's most important one. So you should memorize this also. It is m L to the power minus 1 t to the power minus 1 is what stands for coefficient of viscosity. The next is okay. Next thing that I taught you, this is about fluids. Then I taught you about rotational motion. In a rotational motion, in a circle you will have theta, which is in radians, and the formula is theta is equal to L by R. So L is also length, R is also, therefore it does not have, it's a dimensionless quantity. Dimensionless, but whereas theta's SI unit will be radians. Radians, I told you what is radians. Take a protractor, you have 180 degree which is equal to pi radian. A 90 degree will be pi by 2 radian. A 45 degree will be pi by 4 radian, and so on. Okay, so you understood what is a radian? Okay, so then therefore the theta has to be necessarily in radians, and the formula is theta is equal to L by R, and so it's dimensionless quantity. Okay, so that's about theta. Next I'll teach you angular velocity. Angular velocity is nothing but angular displacement by time, which is radians per second, which is nothing but t to the power minus 1, because theta doesn't have a dimension, time alone is there. Angular acceleration is alpha, which is angular velocity by time, which is t to the power minus 2, which is radians per second square. So you understand that omega is the angular velocity, alpha is the angular acceleration. The words angular velocity is omega, angular acceleration is alpha. This is angular displacement. Angular displacement is what is theta. So you understand different terms from this. This is all in rotational motion. After this, I immediately came and taught you some general basic knowledge in physics, which has got nothing to do with dimensional formula. Straight ஓடினா ஈஸியாக ஓடிடலாம், சுற்றி சுற்றி ஓட சொன்னால் ஒரு மரத்தை கொஞ்சம் கஷ்டம். So the relationship is linear velocity is r times angular velocity, linear acceleration is r times angular acceleration, whereas angular momentum is r times linear momentum, other way around. The angular momentum is more. Okay, the spinning momentum. Can you see the fan spins so fast? You can't beat that angular momentum. How much ever we run, we cannot be equated to that. So the relationship is like this. Are you clear? This is something you need to know. So why? Because I'm going to write an expression for angular momentum. So when they ask you angular momentum, it's L, which is r into p. P is mass into velocity. Okay, so which is nothing but r mv. Let's write the dimensional formula. R is L, m is m. Velocity is L t to the power minus 1. So m L square t to the power minus 1 is the dimensional formula for angular momentum. That you will know only if you know it's r into p, for which you should know this basics in physics. Correct? Then after that, I also would like to teach you what is moment of inertia. Moment is the word associated with rotational motion. Moment of inertia. Inertia means generally mass. Okay, inertia is a property by virtue of which any object will resist change. See, ஒரு பஸ் நிற்குது, நீ உட்காந்துருக்க, திடீர்னு ஸ்டார்ட் ஆனால் உன் பாடி பின்னாடி போகும், பிகாஸ் இட்ஸ் ரெஃப்யூசிங் டு மூவ் வித் த பஸ். ஓகே, ஒரு கார் போகுது, ரைட்டில் திரும்புது, உன் பாடி லெஃப்ட்டில் போகும். ரைட்டில் கார் திரும்பினா உன் பாடி லெஃப்ட்டில் போகும், பிகாஸ் இட்ஸ் நாட் அக்செப்டிங் சேஞ்ச். திஸ் ப்ராப்பர்ட்டி by which a body resists any change is called inertia. அது rotational motionல வரும்போது it's called moment of inertia. So எவ்வளோ ரெசிஸ்ட் பண்ண முடியும்? equivalent to your mass you can resist. அது மேலே ஒன்றால் ரெசிஸ்ட் பண்ண முடியாது. But rotational motionல you will have additionally radius. So it is m not r, m r square. For a change it's m r square, mass into radius square. Are you clear? So moment of inertia is I is equal to m r square. Dimensional formula is m l square. Are you clear? This is about moment of inertia. Then I taught you two different physics about E is equal to mc square and E is equal to h mu, and this is Planck's quantum theory. Quantum physics கேள்விப்பட்டிருக்கல, அதுலலாம் quantum இது h is known as Planck's constant. In the Planck's constant they will ask you for dimensional formula. Planck's constant is h, which is equal to E by mu, energy by mu, or energy into time. Correct? Energy into time. So energy is ml square t to the power minus 2. ml square t to the power minus 2, work done, into t. So it will be ml square t to the power minus 1 is the formula for Planck's constant, for which you should know this basics. E is equal to h mu. Are you clear? Where h is the Planck's constant, which is E by mu, E into t, because 1 by mu is time period. Correct? So that's about Planck's constant. Then I'll also teach you about relative density. Relative density. What is the relative density? Density of a substance by density of water at 0 degrees Celsius. Density of water at 4 degrees Celsius. Sorry, 4 degrees Celsius. Do you know the definition for relative density? Density you know, but relative density means in comparison with water. Density of substance by density of water. So therefore density and density will get cancelled. It will again be dimensionless quantity. It will not be having any dimension. Correct? That's about relative density. So next, let's go to next thing. I taught you what is a velocity gradient. Velocity gradient in the ketchup and honey bottle, I told you velocity by distance. So velocity is L t to the power minus 1 by distance is L. Just t to the power minus 1 is velocity gradient. Let's talk about pressure gradient. Pressure gradient. Gradient word is associated with the distance. So pressure gradient is pressure by distance. Pressure is force by area and distance. So ml t to the power minus 2 is force, by area is L square and distance is L. So it become L and L get cancelled. L to the power minus 2, t to the power minus 2 is the formula for pressure gradient. Okay, next is force constant. I taught you what is a force constant. I'll teach you what is a force constant or a spring constant. Or a spring constant, in which take a spring, have a block here and pull this block with a force. Obviously there will be a restoring force in the spring. This movement is x through which you are moving, and this restoring force, not the applied force, this restoring force is proportional to x. F is equal to k into x with a negative sign, just to show that x is moving in this direction. Restoring force is happening in the spring is happening in this direction. This k is called the spring constant, which is F by x. You can ignore the negative sign. So this is called spring constant or force constant. So that unit will be, force unit is ml t to the power minus 2 by L. So it's m t to the power minus 2. They will also write this as m L to the power 0 t to the power minus 2, because if they want mlt, L is not there, which means L to the power 0, which means it's 1. You can also write it like this, but I am not writing it now like that, leave it like this. So these are the formulas that you are supposed to generally understand and know the terminologies. Okay, now I'll do some questions like this, where they are asking you to identify the physical quantity. They have given ml square t to the power minus 2. What physical quantity is this? What you do, you know force only, which is ml t to the power minus 2. There's additionally one L. This could be force into distance, which is work done, correct? So, or it can also be torque. We also saw that it can also be torque, correct? So then therefore this physical quantity could be work done, or it can also be torque, moment of force, any one of this. Okay, that's the first question. Second question is ml square t to the power minus 3. You have to identify what is this physical quantity. I know only force, okay? So, or I know work done, that's all I know. So ml t to the power minus 2, and what is additionally here is another L and another t to the power minus 1, which is velocity, which is nothing but force into velocity, which is nothing but power. You don't know. You know power is rate at which work is done, but work done is force into displacement by time. So force into velocity is also power. Therefore this is the formula for, this dimensional formula is for power. Are you clear? So this physical quantity is nothing but power. So let's go to next question. M t to the power minus 2. I know force ml t to the power minus 2, which is cancelled by L. Okay, which is force by length, is nothing but surface tension. Therefore this is nothing but surface tension. You can also write it as surface energy, because both of them had the same dimensional formula. Remember, surface energy. So that's the next question. Let's go to fourth question. They are asking what is ml to the power minus 1 t to the power minus 1. Maybe I have mugged it up. It's coefficient of viscosity. ml to the power minus 1 t to the power minus 1 is nothing but coefficient of viscosity, correct? Go up and see, you will understand its coefficient of viscosity. Fifth question, ml to the power minus 1 t to the power minus 2. ml t to the power minus 2 is force, but it's become L to the power minus 1, which means there's L to the power minus 2 which is multiplied, and t to the power minus 2. So this is like by L square, force by area, which is nothing but pressure. Therefore this unit is nothing but pressure. Pressure also and stress also. Remember? So then like that you can write whatever comes your way. You can identify those physical quantities. Next thing is they will ask you for potential. Say what is potential V? Is W by Q. Is the work done in moving a charge from one end of the conductor to the other end of the conductor. But you should know what is Q. I didn't teach you the dimensional formula for Q, but current is just ampere, and current ampere is equal to Q by T. So if you want the dimensional formula for Q, you should multiply ampere into time. There is no direct dimensional formula for charge. You know, SI unit is coulomb. Okay, SI unit of charge is coulomb, but however, the dimensional formula is ampere into time. So then, therefore, this will be work done mL square t to the power minus 2 by charge, which is ampere into time. So when it goes up, this will become mL square t to the power minus 3 into ampere, mLt into a to the power minus 1. So this will be the potentials dimensional formula or volt potential formula. Okay. Next is let's talk about resistance. V is equal to IR. So R is equal to V by I, and V is nothing but W by Q. Correct? V is W by Q into I, and Q is nothing but I into T. So W is I square into T. So mL square t to the power minus 2 for the work done by ampere square and time. This goes up, it will become L square t to the power minus 3 into ampere to the power minus 2 will be the formula for resistance. You understood? So you know what is resistance stand for and what is this dimensional formula. Similarly, we can write a dimensional formula for capacitance. What is capacitance? You know, your mobile has got the power bank has got so many capacitors inside, kutti capacitors. They have the ability to store charge when you connect it to a voltage. So you plug it in the plug point, the charge acquired will be proportional to voltage. Q is equal to C into V, where C is called the capacitance. Therefore, when they ask you for capacitance, C is equal to Q by V. Q itself is current into time by V is W by Q, and that Q again is current into time again, IT the whole square. So then therefore capacitance is ampere to the power 2 time to the power 2 by work done is mL square t to the power minus 2. So when you take it up, it will be m to the power minus 1, L to the power minus 2, t to the power minus 4, a to the power 2. Let me see if it's correct. M to the power minus 1, L to the power minus 2, a to the power 2, t to the power minus 2 to the power 4, t to the power 4. Not minus 2 will go up and become 4. So this is how you write capacitance. Okay, so thus you get to understand different words and you understand how to do this dimensional analysis. Okay, next is why are we learning this dimensional analysis? Will come in application of dimensions. Application of dimensional analysis, where you can convert one system of unit into another system of unit. Like an SI unit can be converted into a CGS unit. What is an SI unit? Is the MK system, meter, kilogram, second. It's called MK system. A centimeter, gram, second is called CGS system. You can convert a SI unit into CGS unit, a CGS unit into SI unit by using this dimensional analysis that we have learned, and I have uploaded a separate video and I have sent you the applications of dimensional analysis which you can see. Okay, for now I'll just still continue with whatever I have to do today. So you understood an MK system and a CGS system, the different system of unit, and okay, I'm going to teach you certain other words. You're clear with till here? I'll teach you certain other words today, such as this lesson is about units and measurements. It's about units and measurements is this lesson. Okay, and at the beginning of the lesson goes like this. You should understand certain words. You know, length generally is in meters, whereas dimensionally it is L. Okay, then mass generally is in kg, dimensionally it is m. Time, the SI unit is seconds, dimensionally it is capital T. Temperature, Kelvin is the SI unit, here also Kelvin is the SI unit, dimensional formula also Kelvin only. Current, electric current is ampere, and here also it's ampere. So I'm going to teach you something called luminous intensity. Luminous intensity, I'll explain to you all this. Is SI unit is candela. Candela, they call it CD. They're not talking about any dimensional formula for it, we'll leave it like that. And quantity of matter. Quantity of matter is called the mole. You know, you would have heard of it, 1 mole and everything. Okay, so these are the various quantities and units that we have heard of. But you haven't heard of luminous intensity, we've heard of rest of the other things. So I'm going to teach you on all this, okay. So in the meter, இந்த மீட்டர் இந்த ஆக்சுவலி மீட்டருங்கிறது என்னது அப்படின்னு பார்த்தீங்கன்னா இஸ் எம் is the distance traveled by light in 1/3 into 10 to the power 8. You know, light travels at a speed of 3 into 10 to the power 8 meter per second, which means it's covering so much distance in 1 second. So 1 meter is the distance traveled by light in 1/3 into 10 to the power 8 of a second. Because Purida, you understood this? Okay, that's about 1 meter. What is 1 meter? It's the distance traveled by light.
So minus 2 into 10 to the power 8 if this goes up.
1/3.
Yes, ma'am. If this goes up. This
10 to the power minus 8 will come.
and this
1/3 will become decimal number. This will be decimal number. 1/3 you have to divide. You can leave it like this. That's just the definition. So it's a distance traveled by light. Dimension formula is over. Don't confuse yourself with that. This is completely different. This is about what is 1 meter. The scientists decided that we all follow the same thing for 1 meter. We all know only that 1 meter scale. Correct? That's not the way they look at. They look at the distance traveled by the light in 1/3 into 10 to the power 8 of a second. Is known as 1 meter. So they'll define what is 1 kilogram. 1 kilogram. Okay, every lab, there'll be a big centralized lab in UK, US. We all have to speak in same language. No? See, so then therefore they'll have one cylinder whose diameter is the same as the height. The diameter and the height and the diameter are equal. It's made up of platinum iridium. It's a platinum iridium cylinder, an alloy of platinum iridium cylinder whose diameter is equal to height. They'll have that kind of a block cylinder which measures exactly 1 kg. So 1 kg is that mass of a prototype. This is called a prototype. The prototype is nothing but a platinum iridium alloy cylinder where diameter is equal to height, and that will always measure 1 kg. In our lab also there will be this platinum. India every country will have this lab in which the standard measurements 1 meter in 1 kg adku standard they'll have follow one thing. It's made up of platinum iridium cylinder. Are you clear? Whose diameter is equal to height. That's known as kilogram. Let's see what is 1 second. What is 1 second? But we can't, the scientists are saying 1 second is about, they took a cesium. They took a cesium 133 atom. And in the ground state, ground state is when n is equal to 1. The atoms are slightly vibrating. The vibration, for one vibration is the time taken. The cesium 133's one atom's vibration in the ground state takes a time period which is 1 second. 1 second is the time taken for the transition between two hyperfine lines of the ground state of cesium atom. So just forget about it. For the vibrations in the ground state takes 1 second. Leave it like that. For cesium 133 atom is something you need to remember. So let's go to fourth. What is 1 ampere? You know how scientists define 1 ampere? They took two parallel wires and they passed current through it. A current carrying wire produces a magnetic field. By right hand thumb rule, there will be magnetic field inward and here there will be outward. For this wire there will be inward and here there will be outward. There is the magnetic field and also current. When there is magnetic, there will be a force which is called BIL. Magnetic field and current is there. There will be a force on the rod, and the force may be attractive. But the current is going in the opposite direction, it may be repulsive. So then they saying when it experiences a force per unit length of 2 into 10 to the power minus 7 Newton per meter. 2 into 10 to the power minus 7 Newton per meter. That current which will be flowing here, that's what is called 1 ampere. So 1 ampere is that current which can flow through two parallel wires in the same direction or in the opposite direction when it experiences a force per unit length of 2 into 10 to the power minus 7 Newton per meter. Appadi they are defining 1 ampere. So let's go to next thing that they are defining, a Kelvin. Next they are defining about Kelvin. Kelvin is a temperature, right? Okay. They are saying 1 Kelvin is 1/273.16 of thermodynamic temperature at triple point of thermodynamic temperature at triple point. What is this triple point? I'll tell you what is this triple point. Thermodynamics or physics padi paaprama. Adula enna avuna water can exist in 3 different states. You know, it can exist in liquid, it can exist as solid and also as vapor. 3 states ஒரே நேரத்துல இருக்கும். How is it possible? All the 3 states will coexist. And that temperature is 273.16. 0 degrees Celsius is 273 Kelvin. But 273.16 la the water is existing at, that's called triple point, at which the water exists in 3 states in thermodynamics. So it's 1 Kelvin is 1 by 273.16 of the thermodynamic temperature at triple point. Are you clear? You understood what is a triple point also? So that's about this. So that's about what is 1 Kelvin. Then I'll teach you what is candela. Candela is the SI unit of CD, luminous intensity. SI unit of luminous intensity. What is luminous intensity? How bright is the light? How luminous is it? That intensity. Okay. So luminous intensity is nothing but so candela is the SI unit of luminous intensity in a given direction. In a given direction. You know, the light is giving light only forward. Torch edutachina munadi dhaan irukku. So in a given direction, அந்த மாதிரி imagine பண்ணிக்கோ. Luminous intensity. Candela is the SI unit of luminous intensity in a given direction that emits light. Emits monochromatic light. Monochromatic means single wavelength. Monochromatic light of frequency 540 into 10 to the power 12 hertz. 1 candela is the SI unit of luminous intensity in a given direction that emits monochromatic light of frequency 540 into 10 to the power 12 hertz. Both. That's about candela. Okay, next is, let's talk about mole. What is 1 mole? You must have studied about mole in chemistry. It's that amount of molecules or atoms present in molecular mass in grams. Molecular mass in grams. Did you understand mole clearly in the school? You didn't understand?
Didn't teach to that topic.
10th standard it's there. Okay.
They omitted.
They omitted. I'll tell you what is 1 mole. Okay. You take oxygen. Is the 8th element. 16 is the mass number. Atomic mass unit is the mass. Correct? 16U. But convert it into 16 grams. Then count the number of molecules. It will be exactly 6.023 into 10 to the power 23. This is for oxygen. Take nitrogen. 7th element. 14U atomic mass. Convert it into 14 grams. In the molecular mass in grams, take it and count the number of molecules. It will be exactly 6.023 into 10 to the power 23. So 1 mole is that amount of molecule or atom present in molecular mass of substance in grams. Are you clear? Clear? So that's about 1 mole. You can define it. Is the atoms or molecules present in molecular mass of any substance, any molecular mass of any element in grams. Molecular mass of any substance in grams. Okay. So next is I'll teach you what is a radian. Radian, you already know, in a circle the central angle is called radian, and you know theta is equal to L by R. Now in a sphere the central angle is called steradian. Football எடுத்துக்கிட்டேன்னா the central angle is called steradian. Omega மாதிரி, okay, ஓம் மாதிரி போட்டுக்கோ. It's called steradian. Sphere radianங்கிறது சர்க்கிளில், ஸ்பியரில் it's called steradian. Steradian is represented like this, where there will be surface area, not arc length. There will be an area. So there will be a surface area by radius square, r square. Again, this will also be dimensionless. So these are the extra things that I taught today. And apart from that, I also gave an introduction to units, such as smaller units, larger units and stuff like that. Once again, I also taught people what are how are bigger units represented, how are smaller units represented. So kilo means 10 to the power 3, kilogram 10 to the power 3. 10 to the power 6 means mega. Kilo is 10 to the power 3, 10 to the power 6 is mega, and what to say, then there are also bigger units other than mega, which is giga. Okay, then tera, you must have heard all this, giga, tera, peta, but we are not bothered about exa, we are not bothered about all this. So it's like 10 to the power 3 is kilo, 10 to the power 6 is mega, 10 to the power 9 is giga, 10 to the power 12 is tera, 10 to the power 15 is peta, 10 to the power 18 is exa, but we don't use any of this, we'll only use till kilo and mega. These are the bigger measures. Okay, smaller measures such as, I'll tell you, 10 to the power minus 15 is called Fermi. Then 10 to the power minus 12 is called Pico. 10 to the power minus 10 is called angstrom, A-N-G, angstrom. Okay, angstrom. It's represented 1 angstrom. It's 10 to the power minus 10 meters. Pico is 10 to the power minus 12 meters. Fermi is 10 to the power minus 15 meters. Are you clear? Fermi, pico, angstrom. Then micrometer, 10 to the power minus 6. Micro. Nano, I forgot. Nano is 10 to the power minus 9. Okay, so these are the various smaller units. These are the various larger units. But there are really, really larger units on Earth. Such as we should know what is light year. 1 light year. 1 light year is the distance traveled by light in 1 year. 1 light year is the distance traveled by light in 1 year. You know, 3 into 10 to the power 8 meters in 1 second. How much is the distance traveled by it in 1 year? 1 year has got how many seconds? 365 into 24 into 60 into 60. So you cross multiply this and you will get 1 light year to be 9.467 into 10 to the power 15 meters. So this is 1 light year's value. You should memorize it. 9.467 into 10 to the power 15 is 1 light year. This is the bigger unit that you're coming across. The second bigger unit that I'm going to teach you is about, so I had taught you what 1 light year is. Now I'm going to teach you what is 1 astronomical unit, AU. 1 astronomical unit is the mean distance between the sun and the earth. So you know the sun is at the foci and the earth is revolving around, and there's perihelion, aphelion, there's average distance. So it's called mean distance between the sun and the earth. Mean distance between the sun and the earth is what is called astronomical unit. Okay, and 1 astronomical unit or value, you should mark it up, that is 1.496. If you see, this is getting juggled. 9.46 la anga 496. 1.496 into 10 to the power 11 meters. This is 1 astronomical unit. The next thing that I want to teach you is about parsec. What is 1 parsec? Let's see. Okay, an arc length of 1 astronomical unit, when it subtends an angle of 1 second at the center. 1 second at the center. This radius is what is called parsec, and its value is 3.08 into 10 to the power 15 meters is the largest unit. Parsec is the largest unit. See, they kandupidichanga the value na. You know, theta is equal to L by R. L is 1 astronomical unit by R. R is what is 1 parsec. Take it that side, R. 1 astronomical unit by theta, which is 1 second. Okay, but you want a second, this is in radians. You don't know what is second, right? In protractor, you have 180 degree, no? In 1 degree, you will have 60 seconds. In that 1 minute, 1 degree, you will have 60 minutes. In every minute, you will have 60 seconds. Purida, zoom pani ponena, 1 degree angle kulla 60 minutes of difference. Time Maria. After 1 minute kulla, there will be 60 seconds. So then this is 1 second. You have to convert into radians. So 1 astronomical unit value is 1.496 into 10 to the power 11 by 1 minute into degree. First 1 second into 1 minute is 1 by 60. Into for seconds it should be another 60. And for converting it into radians, it's pi by 180. Okay, because you know pi radian is equal to 180 degree. So then therefore this many radians is equal to how many, this many degree is equal to how many radians. What is this? 1 by 3600 is equal to how many radians? You have to do like this. Okay, this is how you write. So then this value will account to 3.08 into 10 to the power 15, which is the greatest meters that you would have come across. Thank you. Indian. So you know that which is the greatest unit we just saw?
The
Parsec.
parsec.
1 parsec. Parsec is actually it's also known as parallactic second. I'll just spell it for you. Parallactic second. Parallactic second. Parsec. Parallactic second. 1 parsec, whose value is 3.08 into 10 to the power 15 meters. Okay, so 1 parsec is to 1 light year is to 1 astronomical unit. This is the biggest unit, parsec, 3.08 into 10 to the power 15. 1 light year, is 1.946 into 10 to the power 15 again. And 1 astronomical unit is, this is 3.08 into 10 to the power 16. Did I say 15 anywhere? Yeah, 16, because it has to be the biggest unit. So going back, I've corrected it. So its astronomical unit is 1.496 into 10 to the power 11. The fact that this is 16 shows that this is greater than this is greater than this, and this concludes it. Are you clear? And next is about, I'll teach you what is a parallax after you